So we have been prompted to repeat this bit that was affected by a slight network outage. I'm saying that we are finding now distance in a different unit. Initially we were finding distance using kilometers, but now we are introducing a different unit of, like the way in length we have various units measuring length. You can be talking of meters, you can be talking of inches and all that. Also, here we have different units of measuring distance. So the first one that we dealt with was kilometers. Now we want to see how do we go about getting distance in nautical miles. Nautical miles, shortly abbreviated as NM. So we're going to start by a definition as we introduce these nautical miles when we are in great circles, and say that every degree, 1 degree along a great circle is subtended by nautical 60 nautical miles. So if this is a great circle, simply what we are saying is that at its center here, every single degree is subtended by 60 nautical miles. So that is the definition that we need to get at this point, so that when you're talking about a great circle, you know that at its center, every degree is subtended by 60 nautical miles, where nautical miles now is the distance. So here I've put an example that I want us to work on, so that we can say the two points will lie on 0 degrees. That is the great circle. Then we've got some 2 longitudes here. The first one is 40 degrees to the east. We've also got another longitude here. This one. Okay, so let's get to say that is at every single degree at the center will be subtended by 60 nautical miles. So the question is, how many degrees do we have here subtended by this arc? So from our previous discussion, we saw that when the longitudes are on opposite sides, we simply get the longitude difference by adding the two. So this is 40 plus 10. So longitude difference between A and B will be 40 plus 10. That will give us 50 degrees. And we've noted that, or rather by definition, we've seen that every single degree will subtend 60 nautical miles. And here they are now 50 of them. So how many nautical miles will we have here? So distance will be simple in that case. We simply need to multiply 60 by the number of degrees that we have between A and B, which is 50. And that simply gives us 3,000 nautical miles. So when we are working with the nautical miles along great circles, it's something quite simple. Let's take a second example on the same. Find distance xy. I'm going to give you a reference for x. X, y. X is to y is to the south, again 31 degrees east. So we also need to make a quick observation here where the 2 points lie. I want to believe by now we are able to first of all check the latitude. You see, one is to the north and the other one is to the south. As far as the longitudes are concerned, we'll note that they lie, the 2 points lie on the same longitude. That means that they lie on the same great circle, even if one is to the north and the other one is to the south. So in this case, we've got something like this. We are interested with a certain long latitude here, which is 28 degrees to the north. We are also interested with another longitude here, which is 17 degrees to the south. Then the 2 points are hosted by the same longitude. That is the longitude you're talking about. So that longitude is 31 degrees east. So when it is 31 degrees to the east, this is where we now have point X. This is where we have point Y, and we want to find this distance. So that distance falls on a great circle. In nautical miles, again, our concern is just to know how many degrees this arc subtends at the center. How many degrees does it subtend at the center? This angle here. So in that case, we'll get the latitude difference from this point to this. What is the latitude difference? So I hope you still remember, when they are on opposite sides, we add the angle. So that will be 28 plus 17. That will give us 45 degrees. So distance again becomes so simple. So distance x, y, we just need to multiply the 60 nautical miles for every degree by 45. So we multiply that, so that we'll be able to get that distance. Yeah, that is another class task. If we're in a physical classroom, I'd have moved around checking the figure that you're going to get here, of course, in nautical miles. So everybody, again, make sure that the first example on, rather the second example on nautical miles, you compute to the end. So that is simply how we calculate distances along great circles in nautical miles, whether they are talking about the equator or the longitudes. First, the tail end of this, we are going to get a combined exercise. So we are talking about great circles, then next we'll go to small circles in nautical miles. So along small circles. Along small circles. How do we get that distance in nautical miles? Now, when we have a small circle, up here, and we also have a great circle down here, we have said that along a great circle, 1 degree will subtend 60 nautical miles at the center. 1 degree will be subtended by 60 nautical miles on the surface. So we ask ourselves, how about a small circle? How many nautical miles will subtend 1 degree at the center? because that is now going to help us know how many nautical miles are here. So I'm going to pull out two sectors here. I'm going to pull out two sectors. The first one is on the small circle and the other one is on the great circle. So the first one is here, which looks like this. So we want to think about 1 degree. How many 1 degree, how many nautical miles will be here compared to this other sector here, along the great circle, where we have said it's 1 degree at the center will be subtended by 60 nautical miles as such. The other thing that we need to note is that the great circle has a radius capital R, while the small circle has a radius small r. Like that. So the other thing that we also need to remind ourselves is how we were getting this small radius from the great circle. And you remember from our previous note, we noted that this will be given by r capital cos theta, where theta was representing the latitude angle. R cos theta, the latitude angle. So let's relate the two, because these are similar sectors. Because they both have 1 degree at the center, then they are similar. And therefore, and say that small radius over big radius, that is R. And in this case, now you're going to allow me to use R cos theta to represent small radius. So R cos theta, that is small radius, divided by big radius, should give us, let's call this distance now x, because we don't know it, should give us small arc length divided by big arc length. So that is the similarity now. And you notice that because we are talking about the same radius, this r can cancel with that other r, like that. And you'll find that x over 60 nautical miles, x over 60 nautical miles is equals to cos theta. Don't forget that theta is latitude. So in this case, because we are looking for x, we'll make it unknown. So how do we make this x unknown? We get rid of this 60 by multiplying both sides by 60. We multiply both sides by 60. So we'll find that this will go with this, and our x will be 60 theta, and that is distance in nautical miles. So in short, what we observe here is that along any small circle, at the center, 1 degree will be subtended by 60 cos theta nautical 60 cos theta nautical miles. So again, just like what we did in small circles, you'll notice that you only need to know how many degrees you have here, then you'll multiply them now by 60 cos theta. So let's pick an example. Find PQ in nautical miles. So I'm going to give you some points here for P. P will be the point 45 degrees north, 18 degrees east. Then we have Q will be 45 degrees north. It will also be 6 degrees east. So I want to find that distance. So quickly we'll check the location of these 2 points. The first observation that you're making is that they lie on the same latitude. They lie on the same latitude. Number two, they lie on different longitudes. So that tells you that they lie on the same small circle. So the only thing that we'll be concerned about here is to know how many degrees separate them along that small circle. And we say that when they lie on the same side, we will subtract that. So longitude difference in this case will be 18 minus 6 because they lie on the same side, and that gives us 12 degrees. So what we have noted is that along a small circle, every single degree is subtended by 60 cos theta nautical miles. So we want now to get the distance. Distance from P to Q. So we'll simply multiply the number of degrees which is separating the 2 points, and we'll multiply that by 60 cos. Now the value that we put here is the angle of latitude, and you can see that our latitude is 45 degrees. So we'll be talking about 12 multiplied by 60 cos 45 degrees. Again, this is another task that I want us to take up and simplify this, just a very small figure in the calculator, and get that distance. So to wrap it up, that is basically what small circles entails, and in the previous discussion we were also able to see what great circles is all about as far as nautical miles is concerned. So again, I'm going to give a short exercise that you're going to take up just to compute distances in nautical miles. So our subheading is nautical miles, so make sure that you attempt these distances. We are working in nautical miles. So you're just going to pick the values and then you work them out. So let's work that. I'm going to mix them so that at least we'll familiarize ourselves with identifying whether the points lie on the great circle or they lie on a small circle. Let's take the last one. So let's compute those distances in nautical miles. We've mixed them so that will take time at least to digest, so that we'll be able to see whether they lie on the same great circle or small circle. So thank you very much. Until next time, all the best.